All right, hello guys. So if you want to try and graph functions in standard form, if you're sticking with us here, we are going to look at the second type, which is like sort of the simplified form of a quadratic function. How do we get a graph from that? We looked at this the other day slightly where we were finding zeros and just sketching that graph. We're going to get a little more particular here. So the first thing we should introduce you to is, or recall, is the standard form of a quadratic function is ax squared plus bx plus c, okay? You can see in this equation there are no parentheses, so that's the difference between this and vertex form, where you have a x minus h squared plus k. You can change one form into the other, but we are just going to stick with standard form, all right? So whenever you do a standard form graph, you want to start by identifying what is A, B, and C, because you'll need those values to get the rest of your information. Well, A, if our equation is 3x squared, then A is always the number in front of x squared, so A is 3. If we don't see an x or a constant, then we're going to assume there's zeros added onto the end. So B and C are both 0. The axis of symmetry, which is if you have a parabola, right? The axis of symmetry is this sort of imaginary line that cuts straight through the center of your parabola that helps us have symmetry on either side. So that's what we mean when we say AOS. The vertex is the base of that function, okay? So to get the axis of symmetry from standard form, we have to do negative b over 2a. In a little while, we'll learn the quadratic formula. This is the beginning of the quadratic formula, all right? So negative b over 2a, look at what we have for values. A is 3 and b is 0. So we have negative 0 over 2 times 3. Well, that would be 0 divided by anything is just 0, right? So the axis of symmetry is 0, which means the center of my graph goes right through the y-axis, okay? This value here is also the x-coordinate of your vertex, okay? So the vertex has to sit on the axis of symmetry. So if we want to find the y value of the vertex, if we want to know how far up or down that point goes, we just have to substitute it back into our function. So we're going to find f of 0. If my equation is 3x squared, it's 3 times 0 squared, which would be 3 times 0. Remember, always exponents before multiplying, which is just equal to 0. So the vertex is 0, 0. That's the center of my parabola. Now it's asking if it's a maximum or a minimum value. Well, that's determined by A. If A is positive, the graph faces up, and that vertex point is the lowest point on the graph, so it's a minimum. If A is negative, your graph faces upside down, and this vertex point becomes a maximum. So our A value is positive, so that means that we have a minimum. The y-intercept of our graph, well, we can already see it's crossing the y-axis at 0. That's always the same value as C, okay? If the graph isn't centered on the origin, then you wouldn't already know the y-intercept, so this is usually helpful for you, except for when the graph is in the center. And then let's start from there. Let's see if we have the vertex point. Now remember with a parabola, if I just have y equals x squared, the center point is 0, 0, and in a normal parabola we go over 1 and up 1 space, over 1 and up 1 space, because when x is 1, y is 1. 1 squared is 1. We also go over 2 and up 4, because 2 squared is 4. When x is 2, y is 4. So over 2, up 4, over 2, up 4. You get your standard parabola, okay? When a is a larger or smaller number, it's stretching or compressing the graph. So if I want to know, in our case, we have 3x squared, a is 3. So that means our graph is getting vertically stretched by 3. So I'm going to go over 1, but I'm going to go up, not just 1, I'm going to go up 1 times 3, or 3 spaces. I'm going to go over 2, but not up 4. I'm going to go up 4 times 3, or up 12 spaces. Okay, so you're always multiplying this a value by whatever you have for numbers here. Okay, we know it's going up because it has a positive a value. So over 1, up 3 gives me my next 2 points. If it's too tricky for you to graph like that, just remember the larger a is, so if a, need some space here, if a is greater than 1, so let's say a is equal to 5, then you're going to get a really narrow graph. Hopefully you remember that from earlier in the year. If a is less than 1, like 1/2, then you're going to get a wider graph. It's going to go up slower. It's being vertically compressed. So if you have a hard time with how many spaces do I go over and up, just know the bigger the number, the more narrow you should draw your parabola. The smaller the number, the wider you should draw your parabola. And just give it a sketch, okay? So from the center point, we have a stretch of 3. So we're going to go over 1 but up 3 spaces. Over 1, up 3. And then we said we'd go over 2 but up 12. So all the way up here. So you can see how narrow this parabola already is. Okay? That's all there is to it. Domain of a parabola is always, or a quadratic, is always all real numbers. The range here, we're going from 0 on up. So hard bracket 0 to positive infinity, soft bracket. And estimating the zeros, well, we actually only have 1 0 in this case, one place where it crosses the x-axis, which is at 0. All right. So that's how you graph in standard form when you have a function in ax squared plus bx plus c. You identify a, b, and c first. Find your axis of symmetry, negative b over 2a. Plug that value back in to find the vertex point. The y-intercept is the same as the c value. And then from there, if a is a big number, you're going to get a narrow parabola. If a is a small number, sketch a wide parabola. And that's all you got to do. All right, so give that extra assignment.